Dimensional analysis, a method for performing conversions and for problem solving that uses units to set up the problem for you. Suppose that you were asked to solve the following problem, which is really a metric conversion problem. How many centiseconds are there in 60 seconds? Let's go through the steps in following dimensional analysis. The first thing you should always do is read the problem and ask yourself, what are the units that I'm looking for? What would be the units in my final answer once I've solved the problem? And again, our problem was how many seconds, or how many centiseconds in 60.0 seconds. Alright, we're asked to find centiseconds here. So every dimensional analysis problem, I ask my students to start with a question mark, write down the units that you're looking for, followed by an equal sign. Question mark, seconds, equal sign. Next, it's how many centiseconds. Question mark, centiseconds, equal sign. Next, look for some quantity that's given in the problem, some amount that will convert. So here we start with 60 seconds and write this amount over the number 1. No units go on the bottom whenever there's simply an amount of something. We're just trying to make it look like a fraction because everything that follows next, all of my conversion factors, will look like fractions. Now I ask myself, what do I know about seconds and centiseconds? Is there some conversion factor that I could use in order to go from seconds and go directly to centiseconds? Well, this is where knowledge of metric prefixes comes in handy. I know, for example, centi means 1/100th. So there would be 100 small centiseconds in a second. So I could write 1 second equals 100 centiseconds. That would be a conversion factor that would be useful. You might prefer to think of it relating the prefix to the base unit. Another equality would be 10 to the negative 2 seconds in or equal to 1 centisecond. So the prefix for centi appears in front of the base unit, which would be seconds in this case. Both of these are true equalities, so I could use either one of them in order to create a conversion factor. So as I write my conversion factor, look at the units, and in dimensional analysis, if I have one unit in the numerator and that same unit appears in the denominator somewhere else, then I can cancel those units out. So I look at my equality and I write it in such a way that the units that I don't want will cancel out, and I'll be left with the units that I set out to find in the numerator. I'll take this equality now and write it as a conversion factor. 100 centiseconds in 1 second, or 100 centiseconds per 1 second. My seconds can cancel out now. Whenever the units that you are looking for are in the numerator and all other units have canceled out, then you can stop. No more conversion factors would be needed. So now we can stop and concentrate on the math. In order to do the math, multiply whatever numbers appear across the top, divide by any numbers that you might have in the denominator. So 60 times 100 would be 6,000. And of course, dividing by 1 won't change the magnitude of my answer. So the answer is 6,000 centiseconds. We should also make sure that the answer has the same number of significant figures as the measurement that went into the problem. 60.0 has 3 significant figures. Therefore, I should indicate with a bar in the tens place so that my answer has 3 significant figures. I might have chosen different conversion factors as well. The conversion factor that you decide to use will give you the same answer. For example, I might have used conversion factors like this. Question mark, centiseconds, equal sign. Take my amount, write it over the number 1. I could have said that there's 1 centisecond for every 10 to the minus 2 seconds. Dividing 60 by 0.01, or 10 to the minus 2, has exactly the same effect as multiplying 60 by 100, as I did in my first example. So even though we used a slightly different conversion factor, since it is a valid conversion factor, we get the same answer. Instead of 10 to the minus 2, you might have said 60 seconds over the number 1. And for your conversion factor, 1 centisecond for every 0.01 of a second, which is really the decimal equivalent of 10 to the minus 2. So don't be surprised at times if we choose to use slightly different conversion factors, as long as the equalities that we select for making our conversion factors are true equalities, then we will get the correct answer. The dimensional analysis sets up the problem for us so that you can then do the math. It's very important to write the units down as you work with dimensional analysis, because it's all about the units. One more example. Suppose that you were asked to convert 12,000 millimeters into hectometers. All right, in this problem, what are we looking for? We're looking for hectometers. So I would write a question mark. I would write the symbol for hectometer, which is HM. Take the amount given in the problem, write it over the number 1. Be sure and write the units next to your quantity. And next I need to think of a conversion factor, or possibly several conversion factors, in order to go from millimeters to hectometers. Now in a problem like this, I prefer to go to the base unit, meaning I would go to the meter, and then from the meter I would go to hectometers, simply because with knowledge of the metric prefixes, this becomes easier for you to do without having to look at a table. Let me write down some equalities that I am aware of that I know are true equalities. I know that milli means 1/1000th. Millimeters are very small. So there would be 1,000 of those tiny millimeters in a meter. 1 meter is the same thing as 1,000 millimeters. If you're looking at a table or a chart, you might see that milli stands for 10 to the minus 3rd power. Another way of saying that is that one of those tiny millimeters is equivalent to 10 to the minus 3 meters. So there's another equality that could be used to write a conversion factor. I choose to write it like this. There's 1 meter for every 1,000 millimeters. This way my millimeters can cancel out. The same units appear on the bottom and the top, so they could be canceled out. Now I have meters in the problem, and I would like to find hectometers. So what do I know about hecto? The prefix hecto means 100. There would be 100 meters in 1 hectometer. So I might use this conversion factor. You might also say that there are 10 to the second meters in 1 hectometer. 10 to the second power is the same thing as 100. Let me use my first example. I would like meters to cancel out. So when I create my conversion factor, I'll put the 100 meters on the bottom and 1 hectometer in the numerator. This allows my meters to cancel out. Do I need any more conversion factors? Well, I have hectometer in the numerator. That is the unit that we set out to find. All the other units have canceled out, so this tells me that the problem is already set up. I don't need any more conversion factors. So to do the math now, I would multiply 12,000 times 1 times 1. I would divide it by the number 1,000 because it's in the denominator. Divide again by 100 because it's in the denominator as well. And the answer would come out to be 0.12000 hectometers. I've included these extra zeros on the end of my number because the original measurement had 5 significant figures. Therefore, my answer should also indicate 5 significant figures. Now, pause the video for a moment and practice these conversions. Once you're finished with your work, then you can start the video again. Check your answers.